Hello friends, myself Krishna Chaitanya, working with ESE Engineering Academy as engineering drawing faculty. Friends, in this session, we are going to discuss the solutions of General Studies for Engineering Services 2021. Now let's kickstart the first question under engineering drawing. Here we go. Observe the screen, my dears. Focus, come on, observe the screen. In which of the following projection types the object is kept such a way that its three mutual perpendicular edges makes equal angles with the plane of projection and the object stands on one of its corner, my dears. And there are four options listed below. Option A is non-isometric projection, option B is oblique projection, option C is isometric projection, and option D is point of projection, my dears. My dears, and the right answer is option C, whereas option A, option B and option D are invalid. Clear, my dears? Now let us see why option C, isometric projection, is the right one. Observe the screen carefully, my dears. Focus. In isometric projection, all the three axes or all the three edges are mutually perpendicular and at the same time makes equal angles with respect to plane of projection, I mean POP. Clear, my dears? Nothing but here the angle is 120, even here the angle is 120, even here the angle is 120 degree, my dears. Makes equal angles with respect to plane of projection and simultaneously it stands or it is just resting on its corner. Clear, my dears? This is my corner and here it makes an angle of 30 degrees. Clear, my dears? Now let us move with the next question. Observe it. Focus. This is very basic question which we have come across even in our DeepLearn of engineering drawing, as well as this is a direct question which is available in our ESE engineering material. Clear, friends? Now what are the points need to be remembered while dimensioning? Let us solve. What is the first point? Dimensions are to be placed on the view which clearly expresses the relevant features. Of course, dimensioning plays a very significant role in order to describe the features of any object. Is that clear? So therefore point 1 is valid. Let us discuss point 2. Once dimension is marked in one view, it should not be repeated in other view. Yes, of course, even point 2 is valid, my dears, because in case of orthographic projections, while determining or while specifying the dimension of a front view of an object, it is not mandatory or it is not necessary to represent the height already which is done in front view. Again, you need not to be represent in case of a side view. Clear, my dears? So therefore, once dimension is marked in one view, it should not be repeated in other view. Yes, of course, point 2 is valid. Coming back to point 3, dimensions are to be drawn from the hidden lines. My dears, there is no necessity of representing the dimensions of hidden lines as they are already hidden. So option 3 is not a valid point to be remembered. Coming back to option or point 4, dimension should be given from the baseline or center line of a hole. Clear, my dears? Yes, of course, it is right. So therefore, just there are 4 options A, B, C and D, and where there is no point 3, so that is the right answer for question number 2. Option 3 is of course B is the right one, and option A, option C and option D are invalid, my dears. Now let us see this question by using a graphical representation so that you can have a better understanding, my dear fellow friends. Yes, observe the screen, my dears. This is my isometric view. This is my isometric view, my dears. This is my orthographic. This is orthographic view. So how I specified my dimensions, just observe it very closely. This is how you're supposed to specify the dimensions, and point 1, point 2 and point 4, 3 points are satisfying the representation or graphical representation. Observe it very closely, my dears. This is my isometric drawing and this is my orthographic drawing, which is nothing but representation of front view, top view and relevant side view. Friends, let us move with the next question. Yes, observe it very closely, my dears. Observe it very closely. The design of highway interchanges involves the application of geometry of option A circular arcs, option B semi-ellipse, option C hyperbola, option D semicircle. My dears, the right answer is option A circular arcs, and option B, option C, option D are invalid. Let us discuss with a graphical representation. Focus, come on my dears, focus on the screen. Observe the screen, my dears. When during interchanges, road interchanges, observe it very closely. During road interchanges, the geometry or the application of geometry is in the form of a circular arcs. Clear, my dears? It is in the form of a circular arcs. So therefore, option A is the right answer, circular arcs. Focus. Next question. On a multi-view drawing, multi-view nothing but more than one view, my dears, more than one view or more than two views. A visible or invisible line represents the following. What are the following things? First one is intersection of two surfaces. Yes, it is acceptable. Edge view of a surface, even this is possible. And limiting elements of a surface, yes, all three are possible. So therefore the answer is 1, 2 and 3. So therefore the answer is option D, and option A, option C, option B are invalid, my dears. Option A, B and C are invalid. Option D is possible. Let us see how. Observe the screen, my dears. Observe the screen. Let this is my three-dimensional object, iso view. Let the observer stands here. He is determining my front view. So my front view will be in such a position. My front will be in such a way. Clear, my dears? My front view will be in such a way. Clear. Now, intersection of two surfaces. This surface and this surface. All the surfaces are intersecting here. So therefore, point 1 is possible in case of multi-view drawing. And what next? Edge view of a surface. All the edges are visible over here. All the edges are visible. And limiting surfaces. For example, if I determine my top view like this, now I obtain these surfaces like this. So this is nothing but my limiting surface. This part is called as my limiting surface, because here it is making an slant segment. Clear, my dears? Limiting surfaces. For example, I would like to show you one more graphical representation for a better understanding. Observe it very closely. Yes, observe it very closely, my dears. Observe it. You will get a proper understanding. Observe it. Focus. Come on, focus. You can. All the 3 points are valid in this given three-dimensional segment. Nothing but a multi-view, all views, front view, top view and relevant side view. You can observe it very closely, my dears. Now let us move ahead with the next question. Yes, observe, observe. Observe the question. On a view showing assembled parts, section lines on adjacent pieces are drawn in. My dears, what are the options? Option A is same directions usually at an angle of 90 degrees. Option B, opposite directions usually at an angle of 45 degrees. Option C, opposite directions usually at an angle of 30 degrees. Option D, same directions usually at an angle of 60 degrees, my dears. And the right answer is, option B, whereas option A, option C, option D are invalid. Why option B is the right answer, my dears? My dears, let us discuss by using a graphical rendering or graphical representation. Observe the screen, my dears. Observe the screen. Observe the screen. This is nothing but section assembled component. My dears, as per the question, on a view showing assembled parts, section lines on adjacent pieces are drawn in. The answer is opposite directions usually at an angle of 45. In assembled drawings, section lines are drawn at an angle of 45 degrees and they are opposite in direction. Let us see by using the graphical representation. Now observe the screen, my dears, carefully. Observe the screen. These are adjacent pieces of a assembled drawing, my dears. These are the adjacent pieces. This is one adjacent piece, this is one adjacent piece. All these lines are drawn at an angle of 45 degrees. At an angle of 45 degrees, my dears. All these lines are drawn by making an angle of 45 degrees, and look at here, exactly they are opposite in nature, exactly opposite in direction. You can observe it very closely. These two are adjacent pieces and the section lines of assembled drawings are drawn opposite and they are making an angle of 45 degrees and the section lines. Clear, my dears? Now let us move further with the next question. Next question. Oblique projections has the following advantage over isometric drawings, my dears. Isometric drawings. What is option A? Distortion can be increased by foreshortening measurements along the receding axis. Option B. A greater choice is permitted in orthographic top view. Both are not valid. Option A is not valid. Option B is also not valid, my dears. And let us see option C. Circular or irregular outlines on the front face show the true shape. Yes, exactly. Option C is the right answer, my dears. And option D, oblique drawing is often less flexible. So therefore, option D is invalid. Now, why option C is the right? Let us discuss, my dears. My dears, oblique drawings or oblique projections generally nothing but they are parallel line projections. Observer is at infinite distance and simultaneously the rays of vision or the projector rays from the observer's viewpoint or observer's eyesight will be parallel to each other, but they will not be perpendicular to the plane of projection, but they will be inclined to the plane of projection, my dears. They will be inclined to the plane of projection, and simultaneously in oblique drawings, the front face or the front view of the object always represents true shape. Clear, my dears, irrespective of circular or irregular outlines. Always my front view represents true shape in case of oblique drawings. Clear, my dears? Now let us see by using a graphical representation. For example, my dears, just assume this is my POP. What POP stands for? Projection plane or plane of projection, POP or PPP. Clear, my dears? Now here is my observer, the position of observer. Observer will be at an infinite distance from the plane of projection or projection plane. Now I would like to place an object over here. And here the rays of vision will be exactly in such a way. Clear, my dears? In such a way. The rays of vision will be exactly in such a way. So here the rays are exactly parallel. The rays are exactly parallel to each other. But they are not perpendicular, my dears. They are making an angle. Which is exactly less than orthographic. Orthographic means it is 90 degree. But of course, we are speaking about isometric drawings. Clear, my dears? So in case of oblique projections, if my object is either it might be a circular or irregular outlines, always I obtain true shape in my front view of this particular object. In oblique drawings, I always obtain or always represents true shape, Clear, my dears? Because this surface, the front view surface is exactly, the front face is exactly parallel to POP or PP. Is that clear, my dears? So therefore option C is the right answer, my dear. Circular or irregular outlines on the front face show in their true shape. Clear, my dears?